I'm not going to introduce myself at this time. I want to talk about MGWT, something we started, what was it, like back in 2009, I think. I want to give you the idea why we did it. So there's several reasons to actually, if you're thinking about applications, of actually going native. Going native, you'll have good performance, and you can use any device features. That's the way the people building the platform intend you to ship applications. You can go into any app stores and it will just work flawlessly. But there's also some bad in native applications. And of course, you have to build once per platform. And if there's more evolving platforms, it's going to become more work. And these platforms are competing against each other. So they're quickly charging out new versions that constantly gets you out of sync, and you have to do some work in order to keep up, and so on and so forth. Nobody can afford to break a web application or to break the web in general. You can't, with the next iOS update, you can't break 50% of the web applications. But it's perfectly fine breaking 10% of native applications. So you kind of need experts per platform which deal with all the churn. And because of that, you're going to have higher costs because you have to have more people involved. And worst of all, people have to install that stuff first. Most of the interactions are done instantly. So people go somewhere and they want to do something, and now you're telling them you have to first install an app. Who's liking that thing from LinkedIn? If you just follow link, please install our app first. It's just horrible. But there's also some bad in web applications, of course. Quite obviously, in web applications, I can't just take a picture. It's just missing. There's no API for that. And there's no easy way of getting your web application to a store and getting visibility within the App Store or Google Play. But the web is actually a little bit more superior to all the native applications because it's built on a common standard. And you can build things once, and they remarkably almost run anywhere because that's exactly what the web was designed for. And in order to do that, we need a couple of tools to do a really good job for that. So what do we need? Well, in this talk, we're going to talk about how to do this with GWT, but GWT doesn't have any good mobile widgets, so this is where MGWT comes into play. And we're also going to talk about Phonegap, which is a way of taking your web application and running it on a phone, but packaged as an application, not as a web application. So first of all, before we drill into any of this, how does it actually look like? What does a MGWT application typically look like? And with every framework, there comes a default look, and of course, MGWT also has a default look, and this is how it looks like. The default look you're seeing here is intended to look just pretty thin, easily themable. So people can build their own views on top of that, and their own skinning. So it works on tablets, actually all kinds of different tablets, and has many different widgets in there. Because this is GWT and you have a notion of permutation, you can say, well, for iOS, I want to have this particular styling, and for Android, I want to have this one, and for a web application, I want to have this one, and for Windows Phone, you want to have this one, and so on and so forth. So you can just have completely different styling depending on the platform. And of course, most of the MGWT applications shipping, you're looking at them and you don't even know they're MGWT applications because it's very easily customizable. So this, for instance, is a MGWT application doing traffic alerts in Washington State in the US. You can see how much traffic there is on your route. You can see how ferries are doing and so on and so forth. Or the DoubleClick team at Google launched a mobile application for bidding just to works easily as well. So let's take a look at the different technologies involved. Of course, there's obviously GWT, the Java to JavaScript compiler. Then there's MGWT as a mobile library for all this stuff, and then there's Phonegap. So let's briefly touch on GWT and why it's a good idea, because I touched on this before, but performance in GWT is one of the key things we're optimizing for. And especially on mobile, performance is very critical. You can get away with a lot of stuff on a really fast CPU on the desktop, but you can't do that on mobile. So if you start thinking about new frameworks, test them on mobile first and see how they're doing. And if you get people from one big JavaScript application framework excited about two-way data binding, try it on mobile with a couple of bindings and see how it performs. And don't take the biggest phone you got. Take a phone that's 2 years old and see how it performs. Well, anyway, so first of all, the GWT compiler compiles Java to JavaScript. But the generated JavaScript is highly efficient. And we're able to compile one JavaScript per browser, or per phone, per tablet. We can configure that as much as you like to. And we're mostly good in performance because we perform things like dead code removal. We do lots of inlining, which enables other optimizations. We do renaming. We even output your code in a way where it's better being zipped by gzip. And we have a secure caching mechanism that actually works. So let me give you one idea of the kinds of optimizations that the GWT compiler does. Let's say you have a class shape, and you have a subclass circle. So you could have all kinds of different shapes, like rectangles, I don't care. And this simple piece of code, it's instantiating a circle with a radius of 2, and then you want to know how much space is this actually covering. So the GWT compiler looks at this kind of code and says, well, what can I do about this? And the first thing it says, well, I can do some type tightening here. So it looks at shape S and says, well, I know shape S is actually of the type circle. It's quite easy to do if you know all of the program. And if it does that, it can actually look at this abstract function on shape, which is getArea, which you don't have any implementation. It can start do inlining for this function. So it starts inlining the code. Then it basically looks like this. So now it does another look. And it says, well, I know what math.pi is. It's a constant. And I know what radius is actually at this time of the program. We just inputted it as 2. So it does constant evaluation, and this is what actually ends up in your program. So this whole class is just gone. And we do these kinds of optimizations all over the place. So there's not just one doing that, there's a lot. This is why you get graphs like this. So this is code size in GWT outputted over the amount of widgets you're using. So you can see an application just being empty is like a couple of 100 bytes. That's just, yeah, we're not optimizing for empty applications. And then there's an empty application that just does the hello world. It's quite large. It's like 4K at the moment. We don't optimize for that as well. We don't care. People writing empty applications should do that in JavaScript. And you can see on adding the first widget, and this is on an old slide, by the way, you can see it somewhat goes up to 25K. But what you see then, the more stuff you add, the less it grows, which is exactly what you need for big applications. The more stuff you add, the less size. And MGWT exactly leveraged this kind of capability of the compiler. And it has a couple of things in it. It has basic touch support. It has mobile widgets. It has fast animations done in CSS3. It has multiple themes, UI binder support. It's open source, and it's available from Maven Central, or you can build it yourself however you want to do it. And these are the kind of widgets you can expect to be in MGWT. Basic form widgets, buttons, animated progress bars, dialogues, lots of different input elements, search boxes, sliders, lists that we can scroll through, have headers that show different content. But it actually starts to get interesting once you hit the second platform, because now you can just go with the same application and with a little bit of CSS changes, make it look and feel at home. Just flipping through these. Scroll panels. So which browsers does this actually support? So there's no point in supporting something like iOS 5 because there's no users left on iOS 5. So this does iOS 6, 7, and 8. Same for the iPad. For Android, it does 2.3 to 4.4. We're actually looking with a probably with the next version, we're going to throw out 2.x completely because there's not much users actually left. I think it's down to 11 or 12% in Google Play right now, so within a half year, it's going to phase out. So everything that's basically WebKit works out of the box. It's mostly a CSS thing. Currently, it doesn't support Windows Phone. We considered it a couple of times. The problem is the browser is not really good, so it would require a lot of work on our side, and we're not willing to put in that work for 1%, 2% usage. That's just not worth it. It's easy to add. The way it's written, it's easily extendable, and you can add the CSS. So if people like to do it, we're fine accepting patches for that, but we don't think it's a major thing that should be done right now. So how do you use it? Well, it's like every GWT library. You add a jar file to your class path, and you add an inherits to your project. And that's about it. So let's look at a simple hello world. So you take a normal entry point, from your applications, and you set up your viewport. That's quite important on mobile applications. You need to have a viewport because by default, a mobile browser basically starts out in this scrolled out way because it gives the web page like 1024 by 786 to draw, and then displays that in an overview. What you actually want normally is a view where you're controlling every pixel, so you need to set up your viewport properly. This is what this is doing. There's different options in there that they are documented, and you can set up a different viewport if you need to. Then there's something in MGWT called an animation helper, which lets you transition between screens. So if you want to do animations like this, or I don't know, like this is the way to do it. You add that to the root panel, so it's perfectly integrated with GWT here. Then you use a root flex panel. On mobile, there's a whole different story about layouting your stuff because mobile only has modern browsers. You can just use the flexible box model. It's just there and it works. You add a button, you add that to the layout panel, and then you slide it in. That's about it. So let's look at touch support. There's simple touch events, like you know from mobile, touch start, when the finger touches the display, touch move, when it moves around, touch end, when it goes off the display. Touch cancel is a weird thing that happens sometimes. If you move off the display, it can happen. Or let's say you're doing something and there's an alert coming in from the operating system, it could also be a touch cancel. But MGWT does a little bit more on top of that. It actually has gesture recognizers, so you could do something like a long tap. If you hold your finger down for a while, an event fires for you. Or if you swipe something, swipe start, swipe move, swipe end, something like that fires for you. Same thing for pinch and other motions. So let's look at a simple touch example. There's something called a touch widget in MGWT. There's different ways of getting it. There's even adapter for widgets that don't support touch. They can wrap around and then listen on that wrapper for the events. So you do something like touch widget add handlers, and then you get the 4 basic events, and you just implement them and do whatever you need. You could also do add touch move handler if you happen to only need the touch move handler, but I can't really think of a good way of just needing that. So there's many different input recognizers in there, and you can use them for different use cases. The other thing you need on mobile is specialized inputs. Because on mobile you have this tight space, there's no way of inputting something properly if the keyboard doesn't work for you. So if you're inputting text, you want to have a proper text input keyboard. Okay, that's an easy thing. Same thing for password. But as soon as you're inputting a number, you want to have a keyboard that actually displays numbers by default. Same thing for a phone number, or an email address that actually has the @ right there, or for a date, or a simple picker. Same thing for checkboxes. They work out of the box, and for select elements. So one important thing, if you compare MGWT to, I would say, almost any other mobile framework, it is very, very small. So why is it small? Well, there's a couple of decisions we made early on that kind of keep it small. And if you look at that screenshot, this is MGWT from, I don't know, 3 years ago. There's no image in that screenshot. Everything you see in there is CSS. And you can imagine there's a huge difference between having a binary file, an actual JPEG, giving me that background, or just saying a small line like, oh, my background is a linear background done in CSS. It's a couple of bytes against a couple of kilobytes. And that kind of decision actually adds up. Even the pointy stuff in the back button there, that's just a div turned by 45 degrees with some border colors. That's it. And because we on mobile only have modern browsers, it just works, modern CSS. The other thing we're doing is we're always having minimal markup. So most of the widgets in there, they're mostly one div, and the rest is CSS, because you don't need a huge amount of markup. So if you know how a browser actually comes to render a page, what basically does, it parses the HTML into a tree, it parses the CSS into the tree, and then it matches both the tree to form up the render tree. And the bigger your HTML is, the more cumbersome this process becomes, the more resource consuming. So the smaller your HTML, the faster that process is. There's a little bit about things in CSS selectors that you have to think about, that you're not doing something that's very expensive, but most of the stuff is fairly straightforward. But because this is GWT code, we can actually look at this and say, well, you can see the classes in there, like MGWT slider, they're pretty big. We can also obfuscate them as well. So this is actually taken from a really big MGWT application, and you end up with class names like ABC in there. Another couple of bytes saved. But I think probably the biggest win is dead code removal. I'm not just talking about Java code, I'm also talking about CSS. So this is the old slider on Android on the left side, and on the right side there's the slider on iOS. And they obviously share some code for moving that pointy thing around. But if you look at the styling, they don't share much CSS, they look different. So, and we have this notion set up of different permutations in MGWT, so we actually compile once per device. So we only compile the CSS into a device that's actually needed on that device. So there's no runtime, oh, is this actually an iPhone and I need these colors. It's actually done at compile time, and that reduces size massively. Most of the other frameworks like Twitter Bootstrap, they do this at runtime with media queries, and they try to determine something. We recently did this easy lookup where we compared something we were doing at compile time to Twitter Bootstrap, which they were doing at runtime. It was almost a 10x in the difference in CSS we're outputting. And largely, GWT rebinding is responsible for that. So we can do things like define our own permutations, different screen sizes, and different themes. The other thing you need to get right is layouting, and many frameworks punt on that. And as I said before, MGWT is doing it in a very basic way. It's just relying on the browser to do the layouting properly. So some frameworks do it like this. They have a resize listener somewhere on the window, and if that fires, they start calculating, then they update the DOM, and then they run their layout. The problem is, all that stuff here is done in JavaScript. And JavaScript compared to native code, it's at least 3x, 4x difference. So you never, at least in fast layout, you never actually want to leave native code. And that's a quite strange statement to make for a web developer, because we're never writing native code, aren't we? Well, in a way we are, because with HTML5 and the flexible box model, we can actually configure the layout engine to do our work for us. So if I use the flexible box model and I tell the engine, well, that's the constraints for my layout, and now the phone turns. It already knows the constraints. It actually updates the constraints while turning, and that's done completely in native code and is very fast. So that's the way layouts are done within MGWT. So if you're not familiar with the flexible box model, I encourage you to look it up, because as soon as you start dropping IE9, you can also use it on desktop, and it's a very easy way of doing your layouts. So how are some other frameworks doing animations? Well, some are doing it in a way, they're doing a loop in JavaScript, something like set timeout or request animation frame every 16 milliseconds, and then they update the DOM, which basically looks like this. But inherently, this is going to produce a performance problem, because think about this. You're asking the browser to do an animation. You're saying, I want to move something from here to there. But the way you're doing it, you're only telling the browser, move it a pixel, move it a pixel, move it a pixel, every 16 milliseconds. So there's nothing you can do except redraw the page with that thing moved a pixel. But if you actually use CSS to do your animations, you're basically telling the browser, I want to move this from here to there. And it should take like 300 milliseconds. And now the browser can actually upload this to the GPU and execute it on the GPU, and it runs smoothly without any CPU involved whatsoever. This is how animations are done within MGWT. So we have some JavaScript that writes some CSS, puts that into the DOM, and then it basically gets the GPU accelerated and run on the GPU. So if you look at something like the progress bar, how does that actually look? If the progress bar animates itself, there's an animation with that name. It says, well, I want to do that infinitely. It should run for about 9 seconds, and the animation function should be linear. So there should be no acceleration and no deceleration. And an animation looks like this. You're just saying a keyframe for the animation. At 0, I want to have the background position at 0, and at 100%, I want to have it at 100%, meaning the background just moves over because it just starts redrawing. Because it's an endless background, it looks like it's moving. If you actually profile this, this is the same function running the code that it's actually doing for a native framework. So if you carefully think about how the browser is working and you have some idea of how browsers are doing their work and you're using nice features, you can write very performant apps these ways. So let's go into Phonegap and why Phonegap is important. So, and it's, I think, now I've done this a couple of times actually. Introducing Phonegap is quite easy if you introduce it to people. Let's compare native versus web. What's possible in native, what's possible on web? So, on native, you have to redo things per platform, so you're getting bad development times, therefore high cost. You don't get any portability. Stuff you wrote in Java, you can't reuse it for iOS and vice versa, so redo everything. Of course, you're getting good performance. You're using the APIs that are built to do it. You can call any native APIs, it just works, and you can be in any app store, so that's a big plus. On the other side, if you're doing web development, lots of web developers out there, much more people capable of writing web applications than mobile applications, therefore lower costs, higher portability, so something that works in Chrome on mobile works on iOS and mobile if you haven't screwed it up too badly, but most of the times it just works. Performance is good if you know what you're doing. You need to know how a browser works and how to properly apply CSS and the other things, but then you're actually good. The problem is you can't use any native APIs, so no camera, no storage, nothing like that, and you can't be in any app store. But as soon as you put Phonegap into the mix, everything just works. Because Phonegap is a native application and a web application at the same time, so it gets both benefits without any of the extra costs, a little. So Phonegap is a hybrid. It's both at the same time. And across all these different platforms, like iOS, Android, BlackBerry, WebOS, Symbian, Windows Phone, and so on and so forth, you're getting a consistent API for using all the different device features. Something like accessing the accelerometer or accessing the camera. So you get the same API everywhere. So how does GWT Phonegap play into that? Well, GWT Phonegap just gives you access from GWT to Phonegap. That's about all it's intended to do. It actually gets some nice emulation that Eric touched on earlier. So if you're running it on a desktop browser, for all the APIs, it has a mock in there, so it doesn't blow up. But that's about all. So let's look at a simple hello world. So what you do is you GWT create a Phonegap interface. And that's done for the emulation stuff. So on desktop, you will get back an emulated interface that just basically returns random numbers or something like that. And on mobile, you're getting the actual deal, actually being able to call into something. Then you say, I'm waiting until Phonegap gets ready. This is actually the same deal you're doing in JavaScript. You're saying, well, the framework might need some time to boot on a certain platform, so I'm waiting for an event that tells me the framework is now ready. Most of the time, that comes really quickly. And you also, just in case, add a handler that tells you, well, if you screwed something up, you'll end up here. And then you say, please initialize yourself, and you end up in either one of these. So let's say you want to take a picture. You add some picture options. In this case, you're saying something about quality. You're saying, I want to have back a data URL, and I want you to take the camera, not the picture gallery or something like that. And you just call phonegap.getCamera, .getPicture, you pass in the options and a callback. Remember, web APIs are asynchronously. So for that callback, you get back a failure message. Let's say the person actually denied the camera access. You end up there. And of course, you can get a success. This would be actually the URL, or in our case, because we requested a data URL, that's actually the picture in form of a URL. So we can create a new image, just set the source of the image to that data URL, add it to the page, and we're good. We've just taken a picture in a web application and displaying it inside of the application. So that's the basic stuff. So there's been one major step with MGWT 2.0, where we improved a whole bunch of stuff. Internally, all widgets now depend on the appearance pattern. Hands up, who knows what the appearance pattern is? Almost nobody. So the idea behind the appearance pattern is, unfortunately, I don't have slides for the appearance pattern. The idea behind the appearance pattern is that you'll be able to change the DOM and the CSS of a widget, not the Java code. Because if you write it up properly, if you're able to swap out the DOM and the CSS, you can customize a widget a lot, really, really a lot. So the MGWT widgets all have an interface called appearance, which has two methods. Give me the DOM, give me the CSS. And then we have a UI binder that implements get me the DOM, and we have a CSS or GSS resource that implements give me the CSS. So let's say you want to change a color of a widget. What you do is you basically inherit from our base class and say, well, I actually want this CSS to also include this file, and you change a couple of lines. This way, you can swap out the CSS. Or you really want to customize a widget, you want to completely change the DOM, you also swap out the UI binder part of that widget. I can go into code and actually show how that's supposed to work. And that's a really, really nice way of customizing things to a very, very broad level. We also added new default themes. So the new default themes are basically Android 4.4 and iOS 7, actually going to upgrade to iOS 8. These give you an idea of how to build a complete theme for everything. So there's two ways of using any widget. A widget can have a constructor where you pass in an appearance, so that widget will use that certain appearance, or you can change an appearance globally. So that's the difference. All my buttons look different, or this particular button actually looks different. There's a whole bunch of improvements in terms of performance on widgets, and there's a whole bunch of new icons in there. And we even, despite having more functionality in there, we even decreased output size. So that's quite nice. We dropped about 20%, just because we used to have one big client bundle for all the CSS in there for optimizing. Now we have several split across the appearance pattern that actually enables the compiler to better optimize CSS out. So MGWT is one of these frameworks. If you're only using one widget, only that particular widget actually holds up in your output. It's not like any JavaScript framework where you put in jQuery and then you're downloading 100% of jQuery. You're only downloading the stuff inside your binary that you actually need. And we also added first-class support for the flexible box model. So there's now classes in there that if you understand the flexible box model, that make it very easy to use directly from UI binder or from your GWT code. Oh, I'm missing a slide. So the default theme is in place to be very easily customizable. So the idea is that you don't need to override a whole bunch of things to actually get your colors in. So that's why it's looking very plain and very vanilla. Nothing really serious going on. While the platform themes, they're intended to look closely to the platform. They're not intended to look completely the same. You can put on a lot of work and make them look the same, but that's not the point of the whole thing. We had this discussion earlier today where Eric basically said, you want to have your own look and feel that's the same across iOS, Android, and the web. And you don't want to try to look like a native application. You can look closely, but you should not invest a whole bunch of time. If you want to use any of the platform themes, we always fall back to basic GWT things. You just inherit the platform theme, and it's just set up for you. And if you want to look into the platform theme, all it does, it declares a new variable, Android or iOS, and then rebinds the appearances depending on that variable. That's about all. There's a whole bunch of new icons. There's actually think, a couple of slides. These are the icons available in there, and I think there's a couple more. And the great thing is, if you just rebuild your MGWT application from 1.0 to 2.0, it actually gets smaller, about 20%. That's a nice side effect. Oh, let me quickly talk about the flexible box model. You remember how tough it is to center anything in a browser? And then suddenly someone changes the screen size, and now you need to recenter it at all. Well, this is how you center something in MGWT. Use a flex panel, which is the flexible box model. For people who don't know what a flex panel is, it's basically a flow panel, so a div with display flex. That's about all. And then you say something, OK, my alignment is center, and my justification is center. And that's how you center that image that's inside of that panel. That's it. So GWT is a really great tool for building mobile applications because it optimizes stuff really small. And MGWT provides the missing bits in terms of widgets for mobile. So you can have actually one code base covering desktop, phones, and tablets very easily with that. Because it's all just Java. You just replace the views for mobile with MGWT instead of normal GWT. And while GWT Phonegap just lets you use native features and just deploy in any web store, please keep in mind that browsers are actually getting much better, and something like home screen apps on iOS and Android also work really reliably. And you can also store things offline and cache your application offline. So most of the time, if it's just a business application, you need to store some data on the device, I wouldn't actually go into the App Store if you don't really need it, because you don't have to deal with Phonegap at all. You can just deal with home screen apps, and for most businesses, it's much nicer, because as soon as you update your web server, all the clients automatically update. You don't have to deal with the fact that you update the App Store, and over a couple of weeks, people slowly update to the next version, and some never do. So that makes it much nicer. If you want to have more information, go to m-gwt.com. All the source code is open source. It's stored on GitHub. There's actually quite a good documentation on GitHub about all these things. So let me say thank you, but I'm actually going to go and give you a couple of demos, because I think that's much more valuable. We can do questions now, or we can do it later. I'm going into demos. So what I have here is a basic application, just a normal GWT project set up in Eclipse, nothing else. And there's two modifications to the project. So we reference two libraries. We reference the actual MGWT snapshot, the current snapshot, and I'm referencing the snapshot because of the RC1 in GWT. We fixed a couple of bugs. So if you're doing MGWT right now, you should be using the snapshot, which we're going to release very soon as 2.0.1, which will work with 2.7. And we're also using GWT Phonegap. And the two things we need to do is, in our GWT XML, we need to inherit them. That's about it. So now we have a entry point. So let me bring up the code server and make sure that actually works. My code server just blew up. Okay, there we are. So empty application compiling. Remember, with GWT 2.7, first compile is relatively slow because it's still doing the whole world compile now. That took like 8 seconds. Empty application, if I hit reload now, it's basically doing it instantly. So let's actually put in some code. So the first thing you need to do on mobile is set up your viewport into settings that you actually want. So most of the times you actually want 1 pixel on the screen to be 1 pixel in your web application. That's the normal thing that makes sense, and that's the default for most of the MGWT settings, and you can get that with mgwt settings.getAppSettings. All that does is put in a viewport meta tag into your HTML file. So next thing we do is we create an animation helper. And to actually be able to see that animation helper, we take it and put it into the root panel. It's very important that you never actually take a root layout panel here, just because the layout panels do some magic under the covers, which just breaks everything. For modern browsers, you don't need a root layout panel. It just works with a flexible box model instead. So the stuff that I actually plug into a animation helper is always a root flex panel because it just expands to its parent container. And then from there on out, I can go with other flex elements. So I take a root flex panel. You can see there's another constructor that allows me to pass in a flex appearance. So I could actually pass in an appearance that changes some CSS about this widget. And okay, into that widget, we're actually just going to put in a button. Take the MGWT button. So now we have a root flex panel that contains a button. We probably want to have a click handler. Despite on mobile, there's no click because there's no mouse. So we have something that's more unified. We have a tab handler, which works with a mouse and works with a finger as well. Same thing. So we have a tab handler, and it just put a, I don't know, dialogs.alert. So there's a dialogs class in MGWT that just displays different dialogues. We actually don't need a callback at all. So once we've done that, let me actually give you some overview. So we have that animation helper that we added to the root panel. We have the root flex panel, and we add a button to it. In that button, we have a tab handler that displays a dialog when clicked. And now all we need to do is say animation helper.go to. We go to that panel that makes the panel appear through an animation, and we can select different animations here. So you do animations dot, let's just do a simple slide, so the whole panel would just slide in from the side. And, oh, my browser is way too big. And there it is. So that's a basic Hello World example. So I could go over all the different widgets, but the best way to explore all the widgets is just to take a look at the showcase. They're mostly all in there, and then take a look at the source code and how they're explored. Let me give you one simple example. The widgets almost all implement the GWT interface you would expect. So a slider that has a value while you go up and down implements, of course, value change events. So I can do something like, let's rip out that button. I can do something like set up a slider. And again, if you look at the constructors, there's 2 different constructors. There's the default slider, which will use whatever I've just selected as the default appearance for that application. But I could also be passing in an instance of a different appearance. So if I need to restyle one particular slider, that's how I would do it. So we take the slider, add it to the root flex panel. And by the way, these all work in UI Binder as well. So you're not bound to actually just doing Java coding here. And we can just say slider add value change handler. Probably we want, let's actually put in a label. So some widgets which are already catered enough in GWT, we don't even have a widget for that. We can just fall back down to the GWT widget. That's the case with a label. Let's put in this one. Let's do a label.setText. Just get the value from the slider. By default, the slider outputs something in between 0 and 100. And is it added? Yeah, should work. Looks good to me. So we're compiling this now. And there it is. OK, this is how you basically work on desktop or on a mobile device. So what you do is you set up super dev mode to have these fast recompiles. So once you've already hit code, it's basically instant. And you set up your devices on the table, and you reload them and take a look if everything's actually working properly. You can also remote inspect using the Chrome DevTools or using the Safari inspector for iOS devices. That works as well. But it actually gets quite interesting if you actually come down to Phonegap development, because we recently spent some time to make super dev mode working on a Phonegap environment as well. And I actually want to show you that because it's quite neat. There's no need to redeploy the native application to a device anymore. You deploy it once, you set it up with super dev mode, and while developing, you basically just reload. Same thing like I do on desktop. So let me try to get that up and working. So I just attached a tablet to my computer, and it's actually showing up here. Nice. So you can throw out this. We don't need it. So the first thing you need to do is, in order to use Phonegap, you need to have a Phonegap project. So people always ask me what's the difference between Cordova and Phonegap. Cordova is the open source project that was donated to the Apache Software Foundation, which is, of course, on Apache 2.0. Phonegap is the branding from Adobe. That's about the difference, and Adobe has some services on top of that. So for all of the talk, you can think of Cordova, the open source project. We don't care about the extra stuff that Adobe does. There's some nice stuff in there you might want to take a look. Their build service, which just builds everything for you. But on this machine, I actually have set up the Android SDK and the iOS SDK and all that stuff. And I'm just going to try to do live a new application. So I have the Cordova command line tools installed, which is basically running Node on my machine. And I can do something like Cordova create hello GWT. And this will create a new application for me. So let's go into that application. Inside of that application, it's basically now empty. If we open it up, there's a couple of things in there. There's a config for my projects. There's a www folder, which will contain my web sources. So this is basically where the GWT compiler outputs for production compiled JavaScript for the application. There's a platforms ordner folder, which currently contains nothing because I haven't added anything. But if I add Android, there's going to be an Android project in here. If I add iOS, an iOS project, and so on and so forth. You can actually open them up with Eclipse or with Xcode or the stuff that people use for Windows Phone. I have no idea. But that's how it works. So here we go. So now the next step I need to do is I actually need to go ahead and add a platform. So this is how I do it. I say Cordova platform add iOS, and this will add an Xcode project. That's about it. Then you do the same thing for Android. And now we have, if we take a look again into that folder, we now have an Android project and we have an iOS project. So Cordova consists of so-called plugins. So if I want to shoot I want to use the camera, I need to install the camera plugin. So all the APIs are provided by plugins. So I could have an empty project like we have now with no plugins at all. So there would be no point in using with Phonegap at all because there's nothing you could call. But we want to take a picture. So what we do is we add 2 plugins. Cordova plugin at, what is it, org, Apache, Cordova.device. So this is the device plugin, which gives me information like what version of the operating system you're running, and so on and so forth. This is bad. I have no internet connection. Let me see if I can quickly fix this. The problem is I have the devices for demos in a different wireless. Let's see how we can actually do this. So let's add the device plugin. That worked. And we also need the camera plugin. So what this is doing, it's pulling down native code and it's pulling down a little bit of JavaScript. And now I can basically say something like navigator get camera, and I can access the camera on a device. Okay. So let's just call Cordova run Android. Run Android, I'm not sure. So what this does, it does a complete build of the Android project and basically copies that on this tablet. Is that actually viewable? Just a little bit for everybody. So it's still building. First build takes a while. Okay, there it is. And it's now starting up an emulator. Why is it doing that? And now my MacBook froze. Is it still outputting video? Yeah, it is. But nice. Never happened to me before. No, I've done this many, many times actually, and it never failed so miserably. No, it's actually the machine is actually completely gone. Okay, this is actually rebooting. So let me speed up the thing. So here's what I actually would have done. So in order to get SuperDev mode to work, you can't really copy the compiled JavaScript into the application and then shove it off to the phone, because every build would take like at least 10, 15 seconds. That's not what you actually want to have. You want to be able to iterate really fast. So what you do is you copy a small JavaScript file on the device, you set up, you tell the device where is SuperDev mode running by giving it the IP, the port, and the name of your module. And then every time you hit reload, it just does an automatic recompile. The same thing it does on desktop, but you can do the same thing for mobile as well. So let's see if that actually now works. Okay, I just blew up a whole bunch of stuff. This is actually how my Eclipse is now looking. I think I'm not going to recover with this in 1 or 2 minutes. So let me try to finish this up properly. So what you normally do is you take out that file, and let me actually give you an idea of how that works. So this is our Phonegap project. So what you end up doing is, this is your www folder. This is where all your resources go. And in there, you just have an index HTML file. So for a production compile, you just compile your GWT application, you copy it over, and put the script no tag, the no cache script include into there, and it just works. But that's not something you want to do, a production compile, then rebuild the application and deploy it. You get a debug lifecycle of like a minute or something. That's not what you want. So what you want instead is you want to have a little bit of JavaScript in there that tells the application where SuperDev mode is running. And that bit of JavaScript is actually located where? So there's a small file that you can download from the GWT Phonegap project called GWT Phonegap-stn. And within your HTML file, you just include that. You include Cordova for running up your application. You place in 3 meta tags, one for the IP address of your code server, one for the port, and one for the module name. And then you include that little piece of JavaScript, and it sets up everything. So every time you load the application, it just recompiles. That's about it. I'm not going to retry this. It was bad enough. Okay, thank you.